Hi guys, we are going to be looking at factoring polynomials that can be written in quadratic form. This is going to look really familiar because you already know how to factor quadratics. So let's take a look at what we're talking about here. So if I were to look at this polynomial, it's a trinomial. I've got 3a to the fourth plus 12a squared minus 36. I can apply the quadratic form, standard quadratic form to it. I'm going to start by using, instead of x's, I'm going to use u. So au squared plus bu plus c is what we're going to use. I'm going to take each u and replace it with a squared and vice versa. So that means that if I had u squared, that would be a squared to the second power. So every time I see a u, or every time I see an a squared, that can be replaced with u, and vice versa. So here's what I'm talking about. Initially, I have 3a to the fourth in the original quadratic, or the original trinomial. I'm going to change that a to the fourth such that it's a squared squared. That's a to the fourth still. And then, of course, a squared just to the first power. Wherever I see an a squared, I can change that to a u. So I'm going to replace the a squared with just u. So now I've just got 3u squared plus 12u minus 36. All I'm doing really is just rewriting this in a form that looks more like a regular quadratic so that I can go ahead and factor. So now I want to factor this guy. First thing to always check for are common factors, greatest common factor, and in this case that would be 3. So I'm going to factor out the 3, which leaves me with u squared plus 4u minus 12. Now all I have to do is factor this quadratic, and its factors will be, 3 is still here, u plus 6 times u minus 2. Now I'm going to write my final answer with the a squares replacing each of the u's. So the final factors are 3 times a squared plus 6 times a squared minus 2. Again, all I've done is just replaced every a squared is going to just be a u. Every time I can replace a u with an a squared up here, I will, but when I get to my final answer, I have to make sure that all of the u's are replaced with the actual a squared again. So there we go. That's the final answer for factoring this original trinomial in quadratic form. We're going to take a look at another one. So we've got 2x to the fourth minus 19x squared plus 45. Here's my quadratic form again. Each u is going to be replaced with x squared and vice versa. That means that u squared is actually x squared squared. So in this case, when I'm looking at 2x to the fourth, really that's going to be 2x squared squared again minus 19x squared plus 45. Every time I have an x squared, I can replace it with a u. So this is going to be now 2u squared minus 19u plus 45. I can factor that. There are no GCFs in this one, so I'm going to factor that. The factors are 2u minus 9 times u minus 5. Now I get to replace each u with x squared again, so I can write my final answer. And there it is. 2x squared minus 9 times the quantity x squared minus 5, and we're done with this problem. Moving on, one more with a little bit of a twist. This time u is going to equal x cubed, and that's because this is an even power on my original, or on my first term, my leading term, has an even power on it that can be broken up so that x to the 6 is really x cubed squared. So I'm going to let u equal x cubed such that, so then u squared is actually x cubed to the second power. So x cubed to the second power replaces my x to the 6th. 10x cubed plus 24. Every time I have an x cubed, I can replace it with a u, like I did here. U squared plus 10u plus 24. All I have to do is factor. There are no GCFs in this one, so the factors are u plus 6 times u plus 4 Now I just need to write my final answer by substituting x cubed for each of the u's. So here we go, x cubed plus 6 times the quantity x cubed plus 4, and that's my final answer.